This is a brief introduction to functions and some of the notations and language you might come across as you study mathematics. If you haven't done already, you will probably come across function machines, like this one here. It is a simple way of introducing functions. So for this function, whatever we input, we multiply it by 3 and add 1 to produce the output. Let's consider the inputs 1, 2 and 3. We can show this as a mapping where each input is mapped to one output. 1 is mapped to 4 because 3 multiplied by 1 add 1 is equal to 4. 2 is mapped to 7 because 3 multiplied by 2 add 1 is equal to 7. And 3 is mapped to 10 because 3 multiplied by 3 add 1 is equal to 10. More generally, if the input is x, then this maps to 3x add 1. We should also say where x is a real number being any number that exists on the number line. This particular mapping, where a single value is mapped to a single value, can be called a function. Hence why the example is called a function machine. One input produces one output. This particular function can be written like this. More commonly, it is written like this. f of x is equal to 3x add 1. And for specific inputs, we can calculate the outputs like so. We'll use the previous inputs of 1, 2 and 3, and here's how we would write those inputs using this function. But let's take it a bit further. We could, if we wanted to, plot these mappings on a graph, plotting x, the input, against the function of x, the output. We therefore have the points 1, 4, 2, 7, and 3, 10. So we have the input 1, 2 and 3, and the output 4, 7, 10. The input is called the domain. So in this example, this is the set of values that make up the domain, which can be written like so. The output is called the range, and this is the set of values that make up the range. We might let the variable y equal the function of x, that is, y is equal to f of x. The value of y is the output and is dependent on the value of x that we put into the function. So we can also say that y is the dependent variable, because it is dependent on x. X, on the other hand, is called the independent variable. So in summary, the set of values of the independent variable x is called the domain, which in this example is 1, 2 and 3. The rule which is applied to the independent variable is called the function, which is 3x add 1, and the set of values for the dependent variable y is called the range, which in this example is the set 4, 7 and 10. And so the range is dependent on the domain. Here is another function. The function of x is equal to x squared. It could also be written like this. Let's just say you were given the domain, that is the set of values of our independent variable, as 1, 2, 3 and 4, and was asked what is the range. So for the function of x squared, when x is equal to 1, f of 1 is equal to 1. When x is equal to 2, f of 2 is equal to 4. When x is equal to 3, f of 3 is equal to 9. And when x is equal to 4, f of 4 is equal to 16. If we were to show this as a mapping, we can see that 1 is mapped to 1, 2 is mapped to 4, 3 is mapped to 9, and 4 is mapped to 16. And because one input is producing one output, this confirms that f of x is equal to x squared is a function. So the range in this example is the set 1, 4, 9 and 16. If we let y equals f of x, so y becomes our dependent variable, and plot x against y on a graph, we would have something looking like this. If in these two examples the domain is for all real numbers as opposed to a set of specific real numbers, we would have something looking like this. Instead of plotted points, a continuous line. Notice that for y equals 3x add 1, the line is straight, and for y equals x squared, the line is curved. Also, the function in our first example is called a linear function. This is where the variable x is only to the power of 1, that is x. Here are some other linear functions. The function in the second example is called a quadratic function. This is where the variable x is to the power of 2, that is x squared. Here are some other quadratic functions. Notice that a quadratic function can also include x to the power of 1. If the variable is to the power of 3, then this is called a cubic function. Here are some other cubic functions. And where you see a function like this, these are called trigonometric functions. We can also combine functions. Let's use the two examples we've been looking at. So we have f of x is equal to 3x add 1. And because we are combining two functions, we will name the other function as g of x is equal to x squared. Notice that we have used the letter g for the second function. So you might be asked, what is fg of x? Well, fg of x can be written like so. And what this is saying is that we are going to take our function of x, which is equal to 3x add 1, and input the second function, g of x, which is equal to x squared. So wherever we see x, we are going to input x squared. So think of it like this, where x squared is our input. So fg of x is equal to 3 open brackets x squared close brackets add 1, which we can simplify to 3x squared add 1. If we had gf of x, then think of it like this. And what this is saying is that we are going to take our function g of x is equal to x squared, and we're going to input our first function of f of x equal to 3x add 1. So wherever we see x, we input 3x add 1. So think of it like this, where 3x add 1 is equal to the input. So for gf of x, this is equal to 3x add 1 all squared. And this is equal to 9x squared add 6x add 1. Remember, a function is where a single value maps to a single value. One input produces one output. But let's say we have a mapping that maps a number to its square roots. So if we have 4, then this maps to 2 and minus 2. Remember that 2 squared is equal to 4 and minus 2 squared is equal to 4. So 4 maps to plus or minus 2. 9 would map to plus or minus 3. So x maps to plus or minus the square root of x, where x is greater than or equal to 0. Remember that you can't have the square root of a negative number. So in this example, for one input, we get 2 outputs. Therefore, this mapping is not a function. So there is a brief introduction to functions and some of the language and symbols you might encounter. I hope you found this helpful, and thank you for watching.